In my previous video, I worked out this formula. I also talked about how we can do use the Pythagorean identity to do sines and cosines. Those were odd. If you look down here, I've got this odd piece, but the key really to be able to do this is that I've got an even piece with the secant. So what I want to do is use this formula right here to substitute some things out or to rewrite some things in different forms so that I have something that's integratable. And the key derivative rule that we're going to take advantage of here is that the derivative with respect to x of tangent of x is equal to secant squared x. So if I were to come up here, my goal with this, with this one right here was to leave this sign out on its own. So it could become at least the, without the positive or negativeness, the du for these cosines here. So I'm going to do the same thing down here. Notice I've got a bunch of tangents, right? It's the same value, this 5x, and I've got secant, right? What I can do is leave 2 of the secants there, so leave a secant squared there, and then do the same type of substitution that I did above, and I'm going to use this formula right here, this Pythagorean identity, to turn the leftover secants into tangents. I can only do that if this piece right here is even, if that fourth is even. So, as with above, I'm going to rewrite some things. I'm just gonna, well, you know what? Yeah, I will just show side work here. So this is the secant to the to the fourth of 5x times tan cubed of 5x is equal to secant squared x times another, sorry, I should have the 5x. I'm going to forget that a lot in this. 5x times secant squared of 5x times my tan cubed of 5x. Now you probably don't need to show all these steps, like a rewrite. I'm exhaustively showing work here. So what I want you to see is that this piece right here can be replaced with a form of this. Secant squared of something is this tan squared of something plus 1. So this is secant squared of 5x. So that is going to get replaced with tan squared of 5x plus 1. Hopefully that makes sense. From there, I'm going to get secant squared of 5x times, I'll open a bracket just to kind of keep it a little bit better form, times tan squared of 5x plus 1, close bracket, times tan cubed of 5x. So here, you have some choices to make. I think that we want to simplify this thing as quickly as possible. So we know that this is the same as that up there, because we've shown it. So what I'm going to do now is do my u substitution. I'm going to write u is tan of 5x. That makes du equal to 5 secant squared of 5x, which I could then go further and say that 1/5 du is equal to secant squared of 5x. Now, let me show you the things that are going to get subbed. This is going to get that. So it's going to go, well, it's going to go towards the end of the integral because I'm going to use this piece right here. You know what? Maybe I should erase this. Oops. And just to make it so that this is a better form of writing things, I'm going to write the integral dx, and I'm going to actually change my arrow to go like that, so that my u sub here, my color coding will work a little bit better. So those guys right there are going to get replaced with 1/5 du, because this does have a dx on it. Um, and then I just need to replace these other ones. The alternative to doing what I'm doing right now is to multiply, distribute this tan cubed into this and this. But I think that it's a lot easier to just get rid of it and write it as u's as opposed to multiplying them and then doing the u substitution anyway. So if u is tan of 5x, then let me switch colors. We got green. Tan of 5x, that is going to be replaced. And notice I didn't highlight the squared because that's going to be u squared. And then this is going to get replaced. So what am I going to get? This integral is equal to the integral of bracket. Remember, this is part of the du with the 1/5 out front. That's this piece. All right, u squared plus 1, close bracket, times u cubed. And then the dx paired with this gives me the du as long as that 1/5 here is out front. And you should see that, bam, that simplifies very, very nicely. That could then be written as 1/5 integral of u to the 5th plus u cubed du. And then that's really easy to integrate with power rule. It's 1/5 open parentheses, 1/6 u to the 6th plus 1/4 u to the 4th, close, plus a constant, which gives me, I'm going to move that 1/5 in, 1/30 u to the 6th plus 1/20 u to the 4th plus a constant. And then my last step is just to sub back in my u. Remember, u is this tan of 5x. So what do we get? We get 1/30 tan to the 6th of 5x plus 1/20 tan to the 4th of 5x plus constant. I just want you to see that this structure here in this substitution is the same kind of thing that we did up here. And just like this one here relied on having an odd power to leave a single sign to be able to do my derivatives and my du's and u substitution stuff, this one relies on the secant having an even power in order to pair it with the tans.